Hello, can you hear me?
Yes, doctor.
Okay, good. I'm sorry, but the connection is very poor, so I got disconnected. Let me see. Okay, so we've got a little homework. I want to do the homework first. Okay, question number 2.1.10. 2.1.10, which is this. Okay, so let's see. Let me open here a new Jamboard. So again, there's no connection. Well, thought we wouldn't show any comment. No. Do I still have connection? No connection, I think. Yeah. Hello, can you hear me now?
Yeah.
Yes, doctor, we can.
Yes, doctor.
Yeah, I'm so sorry, but the connection is very poor, extremely poor. I don't know what's happening today. Let's hope for better. Let's see. Okay. So the first question is, I mean, this looks familiar. Have we done this one or not yet? I'm not sure. Number 10, no, I think we didn't do it. I think okay. Number 9 also looks.
Doctor, 210, I guess 210
We
we
have
have
done
solved.
What?
يعني عنا قبل بمرة رقم جيش.
واليوم عندنا رقم 10 هلا بيشبهوا بعض.
Okay. So this is new, right? Question number 2.1.10. We haven't solved it yet. It's a new one, right?
Right.
Okay. So let's do it then. Here are the matrices. I'm going to copy them first, and then I will show them to you. So 2.1.10, and the matrices are, let me see, do we need them all? I need to copy, okay, yeah, almost all, except D. I don't need D, so I'm not going to copy D. So A is 1, 3, 1, 2, 2, minus 1. B is 2 by 3 matrix, 2 minus 5, 2, minus 3, 2, and 1. C is a 2 by 2 matrix. Let's squeeze it here. 1, 2, 5, 0. And E is a vector 3, 1. Okay, and the first question is to find minus 3a. So I'll switch now to, this is it, so minus 3a, and this is quite easy. Let's go over it very quickly. It's minus 3, minus 6, minus 9, minus 6, minus 3, and 3. Okay. The second one is to find 3b minus a. So b is 3b minus a. And this is impossible, as you can see from here, right? Because B and A have different sizes. So this is undefined. We can do this simply because the matrices have different sizes. Then AC, if possible. So part C, AC, and let's see, is it possible to multiply A by C? And we see that it is, because A has 2 columns and C has 2 rows. So we can do the multiplication. And let me, okay, I'll try to squeeze it here. So I will copy them now. A, this is A, 2, 2, minus 1. And C, you don't have to copy, of course, but I will, 1, 2, 5, 0. And now the product is going to have, now let me just look at the size of the product. So since the first matrix has 3 rows and the second one has 2 columns, the product is going to be 3 by 2. So I need to prepare a 3 by 2 matrix, and I will. So here's a 3 by 2 matrix. Can you still hear me?
Yes, doctor.
Okay. Okay, so this is a 3 by 2 matrix. And now let's find the entries. So in the 1, 1 entry, I have 1 times 1 plus 2 times 5, so this is 11. And then 1 times 2 times 2 plus 2 times 0, which is 2. And then 3 times 1 plus 2 times 5, which is 13. And then 6 plus 0, which is 6. And then here I have 1 times 1 minus 5, minus 1 times 5, so it's minus 4. And finally, I have 2 here. This is the answer. Okay. Now for the next one, so I think I can duplicate this. So I will, and then I will move here and erase this. Okay, so I will erase now. I will erase now ABC, and write now the remaining parts of this. I don't know of a better way to erase all this, so I'm doing it using the eraser. Maybe there is one, but I don't know how. Anyway. Okay, so just a minute to finish here. Okay, in the first one, in D, we need to find CA. CA, let me see, CA, okay? CA is obviously undefined, right? Because C has 2 columns and A has 3 rows. So in part D, in part D, the product CA is undefined. Okay, and then we have AE. Let's look at AE. This is part E. AE. Yeah, this is defined, right? Because A has 2 columns and E has one. E has two rows. So A has two columns and E has 2 rows. So this is defined, and we're going to get a 3 by 1 matrix. So let's prepare room for this 3 by 1. Okay. And so we can do the multiplication easily. It's 1 times 1 plus 2 times 3, so this is 7. And then 3 times 1 plus 2 times 3, this is 9. And then 1 times 1 plus negative 1 times 3, which is minus 2. Okay, this is the matrix here. And then EA. This is F, I think, yeah, part F. So EA, let's see, can we define EA? So EA, we need to, you see, it's undefined because the number of columns in E, which is 1, does not match the number of rows of A, which is 3, right? So this is again undefined. This is undefined. And the last one is BE. BE. Again, it's undefined, you see, because the number of columns of B is 3, while E has only 2 rows. So this is FG, and then BE is undefined. Okay. Any questions? Then 14, right? Now we have 14. So let's see what's in number 14.
Doctor, في part H.
Yeah. We still have H.
DE.
Let me see. H. Oh, yeah. Okay. So DE. Yeah, I did not copy matrix D. So let me just copy matrix D. Just a minute, please. Matrix D. I will put it here. It's -1, 4, 1, and 3. Yeah. And now let me show you. So here's matrix D. I copied it here, and we want to find DE. Yeah. Okay. So H, need to find DE.
Doctor, it
Yeah.
is -3.
You mean I copied it wrong? Yeah, okay, -3, right? Yes, yeah, absolutely right. Thank you. Right. Okay. So let's do it. So is it possible first DE, D times E? Where is E? E is here. Yeah. We have 2 columns in D and we have 2 rows in E, so it is possible. And the result is going to be we have 2 rows and 1 column is going to be 2 by 1, right? The result is going to be 2 by 1. So I need to prepare a vector like this, right? And in the first entry, in the top entry, we will have -1 times 1 plus 1 times 3. So this is 2. And then 4 times 1 plus 3 times -3, which is -9. And 4, it's -5. That's it. This is the matrix DE. Okay. Okay, let me now switch to a new frame. And this is now number 14. Number 14 is this. Is it possible to choose K such that AB is equal to BA? So I will again copy the given and then I will show you the work. Okay, so this is number 2.1.14, and we are given A, the matrix A, 1, 2, 3, 4, and the matrix B, which is 1, 2, 3K. And we need to check whether there is such a K such that AB is equal to BA. AB is equal to BA. So I need to find AB, the matrix AB, and then find the matrix BA, equate the two, and try to solve for a value of K, if possible. Okay, so let's see, AB. So we need to multiply the 2 matrices AB, and you can see that this is possible because these are 2 by 2 matrices. We can multiply them easily. So let's see what we get. We will get also a 2 by 2 matrix, and the 1, 1 entry is going to be 1 plus 6. So this is 7. And then the next entry, the 1, 2 entry, is going to be 2 plus 2K, right? So 2 plus 2K. And then the 2, 1 entry will be now 3 plus 12. So this is 15 down here. And then the 2, 2 entry is going to be 6 plus 4K. So this is the matrix AB. And now let's find now BA. BA. Again, it's going to be a 2 by 2 matrix, right? And let's find now the first entry. So the 1, 1. To find the 1, 1 entry, I need to use now the first row in B and the first column in A. So it will be 1 times 1 plus 2 times 3, which is again 7, right? And then the 1, 2 entry, so it's still the first row of B and the second column of A. So it's going to be 1 times 2, 2 plus 2 times 4, which is 10, right? So the result is going to be 10, I mean. And then now the 2, 1 entry, so it is 3 times 1 plus 3 times k. So it's going to be 3 plus 3k, right? And the 2, 2 entry, the last one, the 2, 2 entry, we will have for it, so we get now 6 plus 4k, right, as before, 6 plus 4k, okay? And now I want now these two matrices to be equal. So AB, I want it to be equal to BA, okay? So what do I conclude from here? What's the conclusion? The first conclusion is, of course, the sevens are equal, so this is obvious, right? So I mean, let me circle them. This and this, right, will give you nothing new, and so will this. I mean, these are always equal to each other, right? So the only new thing that you will get is when you look at the 1, 2 entry and the 2, 1 entry. I mean, these. I will circle them in green. This one here and this one here. This should be equal, of course, to this and this, respectively, right? So what do we get if we equate them? We get 2 plus 2k equals 10, and the second one, 15, is equal to 3 plus 3k. So from here, what do we deduce? From the first one, we deduce that k is equal to 4, right? And from the second one here, we deduce that k is equal to 4, right? So yes, so the solution is, right, k is equal to 4, right? So k is equal to 4 will make this equality true. Okay, so if I choose k to be 4, then AB, the matrix A times B, will be equal to the matrix B times A. For any other value of k, this will not be true. If you take k to be 1, let's say 0, minus 1, minus 7, minus 11.8, whatever you take it to be, except 4, right? The equality will not hold. This equality will not hold. AB will not be equal to BA, except when you take it to be 4.
Doctor,
Any
I have a
questions?
question.
Yeah, please, yes.
Is it necessary that if AB is equal to BA, then A is equal to B as a matrix?
No, but it could be the case. If A and B are equal, then obviously AB will be equal to BA. But in general, it's not true. If AB is equal to BA, it need not be that A and B are equal. In this case here, we got them to be equal, but in general, this is not the case.
Thank you.
Yeah, welcome. Okay, so the next one was 22, right? 2.1.22. Okay, let's go to, let me here switch to a new frame, 2.1.22. Let's see. Okay, we have this system of expressions and we want to write it in matrix form, right? So again, I will write the given and then I will show you. So we need to write it in matrix form. It's a system in 4 unknowns. Okay, so let me copy it. Okay, so this is 22.1.22, and the system is this x1 plus 3x2 plus 2x3, the first expression, and then 2x3 plus x1, and then 6x3 and x4 plus 3x2 plus x1. Okay, so I copied the expressions, and now I need to write it in matrix form using, of course, the vector x1, x2, x3, and x4. Okay, so the question is, what matrix should I multiply by in order to get my expressions? Okay, so I need to find this matrix here. So I will draw it here, this matrix, okay, such that when you multiply it by x1, x2, x3, and x4, you get back your expressions. You get back the expressions, which are these x1 plus 3x2 plus 2x3, and then 2x3 plus x1, and then 6x3 and x4 plus 3x2 plus x1. Okay, so what matrix should I use here? I'm going to write the answers in red. Okay, and quite obviously, now we have already done this, so this should be already familiar to you, and we can go quickly over this. So we'll have here 1, I'm looking at this one here, the coefficient of the coefficient of x1 here is 1, and then the coefficient of x2 is 3, so I have to write here 3, and then here I have 2, 2, and there is no x4, so this means there is a 0 here. And you see, if you pair this row, if you pair it with a vector, you're going to get back your expression, right? Similarly, now for the next row now, there is an x1, so there should be a 1 here, right? But there is no x2, so I have a 0 here. And then there is 2x3, so 2 here, and no x4, 0. Okay. In the third expression, there's only 6 in x3 and nothing everywhere, right? And for the last expression, I have 1x1, 3x2, no x3, and 1x4. All right, and you can now easily check that if you take this matrix, the one that I wrote in red, and you multiply it by the vector, which you already know how to do, right? Then you're going to get back your expression. You're going to get a 4x1 matrix, and each entry in this matrix is going to be one of the given expressions. Okay? Any questions?
No.
Can you hear me? Any questions? Okay, since you are not answering, I assume that you have no questions. Becker, do you have a question?
No, I said no questions.
Okay, good. And then let's see what's next. Next, it is. Did I skip any? No. Okay. 2.1.24. Okay. 2.1.24. Okay. Okay. So let me copy this, and then I will show you. So the matrix A is called idempotent if A squared is equal to A. Okay. So we need to show that A is idempotent. Okay, now we'll check it. So we need to. By the way, when we write A squared here, and maybe I did not tell you about this. When you write A squared, it just means what you expect it to mean. It's just A times A. So you multiply the matrix A by itself. Okay, and notice that for this to be defined, the matrix A has to be a square matrix, which means the number of rows has to be equal to the number of columns. Otherwise, the operation of multiplication will not be defined. Okay, so whenever you want to square a matrix, meaning you want to multiply it by itself, then you have to make sure that the matrix is a square matrix. It has the same number of rows as columns. Okay, so let me copy it. So this is number 2.1.24, and the given matrix is a 3x3 matrix, and it's this 2, 0, 2. This is the first row, then 1, 1, 2, the second row, and then -1, 0, -1. Okay, and what do we need to check? We need to check whether A squared is equal to A. So here I put a question mark because we need to check this. Okay. This is it. Okay, so let's check it. So I'm going to just multiply A by A, right? And as I said, I'm going to get a 3x3 matrix because the matrix A has 3 rows and 3 columns. So if you multiply, you'll get a 3x3 matrix. And let's see what is A squared. Okay, so A squared, I'm going to prepare room for 3x3 matrix. Okay, and let's now find the 1, 1 entry. The 1, 1, okay? And remember, to get the 1, 1 entry, we need to use the first row in the first matrix and the first column in the second matrix. But here, it's the same matrix, it's A. So first row, first column from A. And let's see what we get. We should get the first row, right? It's 2 times 2, right? Which is 4, right? So you imagine in your head now, you are multiplying the top row. So maybe I should circle it. This is the top row. We are multiplying this row, right? We're multiplying it by now this column. So I will do the column in red, okay? So that's how we pair them, right? And now when you pair, you see the 2 here is going to meet itself. It's going to meet the 2, right? 2 times 2, it's 4. Then 0 times 1, 0. 2 times minus 1, minus 2. So 4 minus 2, it's 2, okay? And it seems to work, right? For the first entry, we had in A here, the 1, 1 entry was 2. And now in A squared, the 1, 1 entry is 2. 2, again, I mean also 2, right? So it's okay, it's okay for the 1, 1 entry. Now let's check the 1, 2 entry, this one. The 1, 2 entry in A is 0 here. This is the 1, 2 entry, right? This is the 1, 2 entry at 0 here. So now here I need to get 0. For this to work, I mean for A squared to be equal to A, right? There should be a 0 here. Okay, let's see, will we get a 0? So how do we get this entry? Can somebody tell me what should I use? What row and what column should I use now to get this entry?
The first row with the second column.
Okay, so good. The first row and the second column. So the first row is already circled. It's already boxed. It's green, right? And now I should use now the second column, this column here. And let's see, do we get what we want? Do we get a 0? Okay, let's see. What do we get? So we have to pair them now, right? So we are pairing. I will maybe do it here. So we are pairing now this row, right? We are pairing it with this column, okay? So this means we need to take the 2, multiply it by the 0, then this 0 multiplied by the 1, and then this 2 multiplied by this 0. And do you see? We get a 0, right? 2 times 0, 0. 0 times 1 is 0, and 2 times 0, 0. So we get our 0 here. Which is okay, right? Because we need to get a 0, and we do. Okay, so now let's move on now to the next one, the 1, 3 entry. So now to get the 1, 3 entry, I need to use now this row instead now, right? This row here. Okay, with this column. I'm saying row, but boxing the column. So this column instead now. The same row, still the top row. Okay. So now what I'm going to do is erase this here column and write our new column, the new column which I'm going to use now. Can you hear me?
Yes, doctor.
Okay, so now this column, we're going to use now this one, 2, 2 minus 1, right? And still the same pairing, this one with this, and this is the box here, right? So let's see, what do we get? We get 2 times 2, 4, 0 times 2, 0, and 2 times minus 1, which is minus 2. So 4 and minus 2, and we get our 2, right? So as it should, because this entry should be 2, because in A, this entry, the 1, 3 entry is 2. Okay, any questions? Do you have any questions about the top row? No questions, good. Okay, so now let's move on to the next row, the second row, right? The second row, and we can do it in the same way, exactly the same way. So now if we look at the 2, 1 entry, if I want now to get this entry here, this one, the 2, 1 entry, okay? So I need to use now the second row in A and the first column.
The first column.
Yeah, so I need to use now this row here, right, with the first column. And I hope you see it. You're going to get 2 times 1 plus 1 times 1 plus 2 times minus 1. So you see that the 2 and the minus 2 will cancel out, and you will be left with just a 1. So there will be a 1 here. Let me do it in black. Okay, there will be a 1 here. And now, again, to get now the 2, 2 entry, so you use now the second row and now the second column. And you see you get 2 times 0 plus 1 times 1 plus 2 times 0. So this is just 1, because the 1 times 0 is 0, the 2 times 0 is 0, and you are left only with the 1. And finally, for the 2, 3 entry, again, you use now the middle row and the last column, right? And you get 1 times 2 plus 1 times 2, this is 4 already, and am I doing, yeah, and 2 times minus 1, right? Which will give you, so 4 and minus 2, this will give you a 2. And now, finally, the last row. To get the last row, we need to use now, of course, the last row in A. This one here, I will do it in blue, this one here, in exactly the same way as before. So we get minus 1 times 2. I'm doing it with the first column. Minus 1 times 2, so minus 2, plus 0 times 1, plus minus 1 times minus 1. So it's minus 2 plus 1, so it's minus 1. And then for now the 3-2 entry, I have to use again this row, the one in blue, and the middle column, right? So you get minus 1 times 0, 0, plus 0 times 1, 0, plus minus 1 times 0, 0. So everything is 0. All right, so the sum will also be 0. And the last entry, the 3-3 entry, will be now minus 1 times 2, plus 0 times 2, plus minus 1 times minus 1, just the number itself here by itself. Yeah? So we get minus 2 plus 1, which is minus 1. And you see that this is equal to A. Right? This is equal to A. And such matrices whose square is equal to itself is said to be idempotent. Okay, you don't have to know this name. Okay, this is what they mean. Just A squared is equal to A. Any questions?
No, doctor.
Then let me move on now to the last one, I think, for today. Yeah, it's 2.1.25. This is the last one. So let's switch here. 2.1.25. For each pair, we did A last time, so let's do B today. For each pair of matrices, find the 1-2 entry and the 2-3 entry of the product AB, and let me write a given. So 2.1.25 B. Okay, the matrices are A 1, 3, 1, 0, 2, 4, and 1, 0, 5. And B, matrix B, is 2, 3, 0, minus 4, 16, 1, and 0, 2, 2. Yeah. Okay. So we need to find the 1-2 entry and the 2-3 entry. Okay, so we need to find AB, right? They said AB, I think, right?
Right, doctor.
Yeah, AB. AB, the 1-2 entry. Okay. So to find the 1-2 entry, I need to use the first row in A and the second column in B, right? So I need to use, let me do it in red. So I need to use this one here, and this is to find this, right? The red one here. And let's see, we get 1 times 3, right? Plus 3 times 16.
Plus 3 times 16.
Yeah, plus 1 times 2. All right?
Plus 1 times 2.
Yeah. So this is 53. Okay. And now to get entry 2-3 entry, so let me switch now, AB now, we need to find now the 2-3 entry, okay? And I will do this one in, maybe in green. Okay. So the 2-3 entry. So I need to use now the second row in A and the third column in B. You see, this one here. Okay. And let's see what we get. We will get, okay, so we will get what? We will get now 0 times 0, right? So it's just 0, of course, plus 2 times 1, plus 4 times 2. All right. And this is 10, of course. And this is 10. And that's it. That's it. So we that's it. This is a 2-3 element, or the 2-3 entry of this matrix. Any questions? Okay, then yeah. So in that case, that's it for today. I'm not going to explain anything new because we're already running out of time. In fact, the time is already over. So see you on Tuesday. On Tuesday, I'm going to start a new topic. We'll do. I will be telling you about the properties of multiplication, and then we'll introduce, hopefully, some transformations on matrices, in particular what is called the transpose matrix, and perhaps also I will be able to tell you about the inverse matrix, how to calculate the inverse matrix, define it, and then calculate the inverse matrix. Okay, see you on Tuesday. Bye.
Thank you, Doctor. Bye.